When you look at the discussions in Energy 101, you realize that an understanding of the fundamentals of what electricity is all about really is helpful, may even give you some insights as to what it's all about. Well, the history of electricity, we can start with the discoveries that were made in the 18th and 19th century. And probably the one form of electricity that was most apparent to everybody was static electricity. And that is an inherent property of nearly every object. So the loose electrons in atoms and molecules tend to migrate to the surface and collect, oftentimes on the end of a point, such as your finger or Harry Potter's wand, if you will. And we build those charges up, like when we pull our sweater off and our hair goes sprung. But inherently, it was very difficult to capture and put to use that static electricity. Well, lightning is probably the most spectacular form of static electricity. And we probably all have that image of Ben Franklin with his kite standing out in a thunderstorm, trying to capture that energy. The truth of the matter is, he and most of the other scientists at that point were struggling with that. He fortunately developed the lightning rod, which got it to ground and, saved a lot of barns and church steeples from destruction. But it wasn't until two Italians came along and developed the first battery. A battery is generally dissimilar metals, let's say copper and zinc, that are separated by an electrolyte. And the earliest ones used brine, or if you like, pickle juice. And those ions migrated. They naturally want to migrate from one metal to the other, from the copper to the zinc. And when you put them together in a battery, then you have two poles at either end. And if you interconnect those, say with a little light bulb in between it, you got the first flow or direct current. So once we have the battery hooked into a circuit, this is a good point for us to look at how we measure what's going on. The two primary components are voltage and amperage. Now, voltage is how excited those electrons are that want to get through the circuit. And amperage is a measure of the flow of those electrons past any given point per unit of time. One way to think about it is the number of electrons that are flowing down the wire. Now, this is analogous to the way they looked at it back in the days when water was a significant source of power. So the waterfall is a great example. So the height of the waterfall is analogous to the voltage. How excited are the electrons? And the amount of water going over the edge is equivalent to the amperage, the number of electrons that go past a point at any given unit of time. And the product of those two, the voltage times the amperage, is power. And the unit of measure is a watt. Now, a watt is a very small unit of power. And when we use it in our house, we generally measure it in thousands of watts or a kilowatt. Now, that particular watt or kilowatt, that power, is the same that we get when we perform work at a given rate, or when we consume energy at a given rate. So there's a connection not only between the electricity, but also to what's going on in the production and consumption of energy and other mechanical items, such as your car, or even what you physically are doing. So to recap, well, voltage, again, is the charge and its desire to get to and balance out with another charge or another body. So from a battery, it's what is the likelihood that the electrons want to go from here to here. Now, amperage is, if you put this in a circuit, like with a light bulb or a motor, is what is the rate that those electrons are moving across there. And the product of those two, how excited they are, and then how many of them are moving at a given rate of time, is power. And again, that's measured in watts. Now, typically, when we buy it in our house and plug it into the wall, we measure those in kilowatts, which is just 1,000 watts. And that same production of power, that use of energy, is the same units and concepts that we have when we use mechanical equipment, such as our lawnmower, or drive our car, or even eat food, curiously enough.